Today, we are going to learn how to draw electron or Lewis dot structure. Throughout the video, we are going to refer as electron dot structure to be consistent. The electron dot structure focuses on the number of valence electrons of that specific element. So if we know an element has a specific number of valence electrons, we can draw an electron dot structure for that element. Now, the beautiful thing about this is that if we look at the periodic table, okay, here I have a periodic table. We have group A throughout the periodic table. These are the representative or the main group's elements. What's so special about this is that the group number, the number of the group A is also equal to the number of valence electrons. So I'm going to draw electron dot structure for each of the group A on the periodic table. Another information that you need to know is the properties of electron. Now, electrons are negative. Because electrons are negative, they are going to repel from each other. Remember when you have a magnet with a north and a north facing each other, what would they do? They repel. So what does that tell you? Like charges repel. But when you have a magnet with a north end and the south end, what would they do? They would attract each other. So that would tell you opposite charges attract, and again, like charges repel. What does that have to do with electron? So let's use X as a symbol for any element. If I were to have one electron here, the other one will be over there. Okay? And then we would have another one up there and another one down here. Remember, valence electrons are found in the highest S sublevel and P sublevel. We have 1 orbitals, 2 orbitals, 3, 4. These are the 4 locations on the Lewis dot structure. What if we have more than 4 electrons? The first one would go up like this in all the empty orbitals, but where would the other one, like the 5th and the 6th one go? They would have to go back and pair them up. So what does that mean? That means we have to pair the electron in the Lewis dot structure as well, or the electron dot structure. So the other one could go be pair over here, and so on, we will have to pair up there. So again, we have 4 general locations where electrons are located that represent each of the orbital. Let's go back to our group 1A, because in group 1A, it's going to have 1 valence electron. So we have the letter X to represent the element. Now, this electron can be over here. It could be over here as well, here or here. So another way of drawing electron dot structure for any element in group 1A could be like this. So these are the possible electron dot structure for the elements in group 1A. What about when we have element in group 2A, which including beryllium and magnesium and calcium? We have the letter X to represent our element. One is going to be over here, the other one is going to be over there. Remember, they don't pair up because we have 4 different orbitals to occupy. Or the other way of drawing is you can have electron up there and down there. Okay? But they cannot be like this. This would be wrong because the electron would go to the empty orbital first. Then over here we have 3 electrons, one there, one right here, and one could be up here or down there. So let's draw another one right there. There you go. Or you can have this. What about element in group 4A? It has 4 valence electrons like carbon. So carbon would be like this, 1, 2, 3, 4. Can we draw another electron dot structure for element in group 4A? The short answer is no, because we only have 4 general locations to draw the electron. What about element in group 5A? It has 5 valence electrons, so X, 1, 2, 3, 4. Now, the second one that's pairing up in an orbital, it could be anywhere over here. It could be here, 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 here. I like to go over there. So let's draw another one. We have 1, 2, 3, 4, and the other one will be paired up right there. So again, there are different electron dot structure because we can place electron in 4 different places. Let's try any element in group 6A, which including oxygen, sulfur. So we have element X, 1, 2 over there. So we complete all the 4 orbitals. So we have to pair the electron in those orbitals, one there and one over here. Okay, could it be right there? Of course. We could have 1, 1, 1. There you go, like that. Okay, let's go to group 7A. We have element X, 1, 2, 3, 4. Going back and pair the electron in the same orbitals, one over there. And the second one, you can pair anywhere right here. So 6, and then we can go right here. So give us 7. What about another way? We have 1, 2, 3, 4, pair, pair, pair. That gives us 7 right there. And lastly, we have the elements in group 8A. There's one exception that you need to know, is that element helium. This right here is the 1s sublevel, which including only 2 electrons, one going up and one going down. So it doesn't have the 3 orbitals like the rest of the element. So what does that mean? That means the electron in helium is going to pair up. It's not like this. This would be wrong if you have helium, okay? What about the rest of the element in group 8A, like neon, argon, and krypton? Of course, we would have the letter X to represent the element. Then we have 1, 2, 3, 4. Go back and pair. 5, 6, 7, 8. In this case, we only have one possible way to draw the electron dot structure for element in group 8A. It's very similar to element in group 4A, because there are only 4 general locations that we can put the electron. And that's it. How to draw electron or Lewis dot structure for any element on the periodic table. What if I tried to trick you? And I say, hey, this element somewhere on the periodic table, let's put silver, Ag, has 1 valence electron. How does that work? Of course, it's going to look something like group 1A, so we put Ag like that. What about if I decide to give you another element like zinc has 2 valence electrons? So of course, it's going to look something like this right over here. So we have Zn, or zinc, 1 dot there, 1 dot there. Give us 2 electrons. The key is looking at the number of valence electrons, and that determines the structure of the electron that you have for that specific element.